Hi Year 12, this is Mr. Seo. So this is now a video on 1D. So again, as before, I've selected some few of the questions from 1D so that you can appreciate the contents that's involved. So before you watch, as usual, make sure you've done your reading of the theory and the examples of the section first. Okay. All right. So question one. So you're given that's an AP and you've got three terms to deal with, then if it's an AP, because it's a common difference involved, we know that T2 minus T1 is equal to T3 minus T2. They have to be the same because by definition, these two are the common difference. Okay, but let's focus on the T2, all right? So if you trying to make T2 the subject, then the next line will be the one. This textbook only covers this, but I'm going to go a step further. So that's going to be 2T2, all right, because you've got those two the same term. Then you get T3 plus T1 or T1 plus T3. So what that means is if it's in sequence with if it's an AP with the three terms in it, then if you double the middle term, that's the same as the sum of the first and the third term. Okay, so that's the same thing. Okay. In fact, I'm going to use this one here to deal with part B and E. All right, so here you've got three numbers, and those three numbers in that order form an AP. So the double the middle term, which is 2m, is equal to the sum of the first and the third term, which is 46. Hence, the middle term has to be 23. Okay. All right. So the next one, now the middle term is 22. So double the middle term, that's 44, is equal to the sum of the first and the third term. So which is that, and hence m has to be 12. Okay. Now if it's a GP, then we know that it's going to form a common ratio. So by definition, that's T2 over T1 and T3 over T2, they must be the same because it's called the common ratio. All right. So as before, we're going to make T2 the subject. So, if you do the cross multiply, square of the T2 is equal to the product of T1 and T3 this time. So that's that. Okay. Now you can go ahead and take the square root, but I'm just going to stop there, all right, because that's enough for me to do the following two questions. So section C, again, three numbers, all right. So by the way, guys, whether it's an AP, a PO, or GP, you can only do this when you have three terms in the sequence. Okay, so square of the middle term is equal to now the product of the first and the third term. Then you get 900, and therefore when you take the square root to get the g, remember it has to be plus and minus because there's no restriction as to g has to be a positive or negative number. So you're gonna have to take both cases. Okay. All right, f, so square of the middle term is equal to the product of the first and the last. So 16 is equal to minus g, hence g equals negative 16, okay? All right. Question 5. So this is the question that involves a simultaneous equation, and this is the sort of question that's popping up a lot in the exam sort of situation. So I would put a star against question 5, okay? It doesn't mean that all the other questions are not that important, but all I'm saying is this is pretty like a frequent question on any paper. So forms an AP, and you were told that the fifth term is 24 and the ninth term is negative 12. So 24, remember you have to use because it's an AP, you have to use this general formula that is the nth term is the first term plus n minus 1 times d, okay? So that means A, we don't know, plus the fifth term, so therefore it's n minus 1, that's 4 times the common difference. All right, negative 12, which is the ninth term, is equal to the first term plus n minus 1, so that's 8d. Okay, now all of a sudden this question is now a linear simultaneous equations to solve in terms of A and D. So subtract that, then you get that, negative 36 equals 4d, and d equals negative 9. Put back into one of these, 1 or 2, then you get A, the first term is 60, okay? All right, so that's first page. Second page, now same sort of deal going on in terms of simultaneous equation solving, but this time it's GP. So you were told the fifth term is 6 and the ninth term is 24. So that means, remember, if it's a GP, the general term formula is now A times r to the n minus 1. So 6 equals, that's the fifth term, so that's r to the 4, all right? And ninth term, that'll be r to the 8. Okay. Now, unlike in an AP situation, if you're subtracting or adding any of these two equations, it's not going to help you at all. Okay. Remember, by the end of the day, at the end of the day, in solving any simultaneous equations is to, in a bigger scheme of things, is to get rid of one of the prenumerals. Okay. So here, the only way to do that is to divide. All right. So that's why I'm dividing 2 by 1. Okay, so then you get 4 equals a and a cancels, r to the 8 divided by r to the 4. By the index law, that's going to be r to the 4. Okay, so notice then here, that's an even power. So whenever you take the, nth root, you're going to have plus and minus associated with it. So that's 4 to the 1/4 as a power. So I can change the 4 as 2 squared. Okay, so you've got then inside and outside indices to deal with. Then what do? You multiply them to get half, and that means the square root. So here again, you've got r to be plus and minus square root of 2. Now, remember, that's only the common ratio. I now have to have the first term sorted. Okay, so to get that, you can now use equation 1 or 2. All right, but here you don't have to use this one here. Notice I said that, put the 3 back into 1, but you can really use this one here because in equation 1 you have to have r to the 4. Okay, so we already know r to the 4. That's 4. That's a nice positive integer. Why don't I put it back in there? Okay, instead of going all the way from here. I mean, you can. I mean, like I said here, but it's the same thing. But that's basically giving you a shortcut. So 4 in there, that's going to be 6 equals a 4a times 4. Hence, a, the first term, is 3 on 2. All right. Question 10. So this is now a very interesting question because this involves a logarithm. Now, in the textbook, they said you have to use a trial and error method. Now, we're smarter than that, so I'm going to do basically pin it down what the actual answer should be rather than the trial and error using algebra, and that is the log rules. Okay, so make sure you know everything about everything on log rules. Okay, so forms in GP, so 25, 5, 1, and so on. So then we can write down the general nth formula. So a times r to the n minus 1. Express everything in terms of 5, so that's going to be that. So that. Okay, so by now this process should be pretty smooth. All right, so the nth term is now 5 to the 3 minus n. Now, we were told that find the number of terms when that is greater than 10 to the negative 6. Okay, so that's what I mean by that. So that's the general nth term. So you need to set that greater than 10 to the minus 6. Now, remember the aim is to get the n, okay? Solve this inequality with respect to n, okay? So I can see that this has a base of 10, so which means you can take the log with the base 10 or the common log, okay? Now, we might ask, well, what if it's not 10 anymore, like 2, 6? Well, then you can take log with base 10, common log, or log with base e, or the natural log, okay? So in this case, yes, you could take the natural log with the base e, but because that's already base 10s, I just decided to use log with the base 10, which is the common log, okay? And so take both sides with the log, then you get that. Notice you don't change the inequality sign because log function is an increasing function, so that's that. And now this is the log rule. So if it's a log with the power there, you can remember one of the log rules says you can bring that as if it's the coefficient of the log. That's what I'm doing. And this here, yes, you get negative 6 log with 10, but remember log 10 is basically 1. So that's negative 6. Remember, we're trying to solve for n, so divide everything by log 5, but you know that log 5 is greater than 1. How do I know? Well, remember the log function, so that's this. Remember the x-intercept is 1. So if it's log with the 5, that's here. So that's where the 5 is. So it's definitely 5. Or if you're not sure, plug into the calculator. And log 5 will give you a positive number. So because you're dividing by a positive number, your inequality sign stay the same. That's important. Okay, what that means is if you have log with number less than 1, like 0.1, then you need to swap the inequality sign, because as you can see, log with any number less than 1, it's a negative number. Okay, but fortunately here we have positive number to divide by, so that's that. And now then, why am I swapping this? Because I've changed the order here. Okay, so instead of 3 minus n, I just swapped it n minus 3. In other words, you did this, and then next step, multiply everything by -1. Hence, I need to swap the direction of the inequality sign, and that's that. And hence, the -3 tossed over, you get this. And at this point, you make sure you use the calculator, and that's around 11.58. So 58. So n has to be less than 11.58. Hence, the last integer value is 11. So first term all the way up to 11th term, they're all greater than 10 to the -6. There are 11 terms that satisfy that condition. Okay. All right. So page 3. So question 12. This is an AP. You were told that these 3 terms in that sequence sum up to be -6. In that case, what's T6? Okay. Now, interesting thing is, here, we're not looking for A, the first term, or the D, the common sorry, not the common ratio, common difference. We're just looking for the T6, that is sixth term. So why don't I just express T4 and T8 in terms of T6? Okay, well, how do you express T4 in terms of T6? Well, it's skipping T5. So to go from T4 to T6, you have to add the 2D on it, okay? All right, so in other words, T4 in terms of T6, it'll be take away 2 lots of the common difference, okay? Why isn't it 1D away? Because if it's 1D, then it's T5, okay? Because T4, so you're skipping fifth term, so that's why you have to take away from 2 lots of common difference. Similarly, then T8 will be T6 plus 2D. Okay, now watch what happens when you add this up. Well, T4 is now T6 minus 2D, and T8 is T6 plus 2D, and these -2D and plus 2D, they cancel, and gives you 3 lots of T6, which is -6. Hence, the sixth term is -2. Sweet, okay? So that way we don't have to deal with the first term and the common difference. Now, alternatively, you might be going, okay, express that in terms of A and D, A and D, and A and D. Then watch what happens here. You've got an equation with 2 unknowns, A and D, and which is impossible to solve. So unfortunately, you can't solve this using the traditional method, okay? So that's why the question says, what is the actual term, the sixth term, rather than what's the A and what's the D, okay? Question 14a. So this is a GP. You got 3 terms, so you can use that idea. Remember, the square of the middle term is the product of the 2 end terms. So that's this. And when you expand it out, then you get that. Remember the binomial product formula. A plus B all squared. A squared plus 2AB plus B squared. Okay, so that's this. And x squared cancels, hence that x equals -12. Question 16. So they give you the scenario A, B, and 1. They form, in that order, form a GP, but B, A, and 10 in that order forms an AP. Remember AB the same, AB? Okay, so from this, we can say that got 3 terms. So that square of the middle term is the product of the 2 end terms. So that's that. Here is an AP, so double the middle term is equal to the sum of the 2 end terms, which is that. Then I have now 2 simultaneous equations. Now, why all of a sudden double the b squared? Because here I've got 2a. Here I've got b squared equals a. So if I double this, you're going to have to double the left-hand side. Okay, so then you get what I'm trying to get at, and that is replace that by this. Okay, so that's what I mean by that. Is substitute 1 into 2. In other words, replace that. So then I get this nice quadratic equation with respect to b. Okay, at this point, you can do the cross method or any other method that you know of. Okay, so then it nicely gets factorized like that, and b equals, you got two answers, possible answers. Again, there's no restriction in the question where it says b has to be positive or negative, so you do need to type both of these values. And now, respectively, by substituting that into either 1 or 2, then you get a to be 4 and a to be 25 or 4. So that's that. Okay. All right, now the last page. Question 17. You were told that these three terms form a GP, but at the same time AP. But that itself, you can see that they all differ by D, so that itself is an AP. So because these three terms also at the same time form a GP, we can say that square of the middle term is equal to the product of the two end terms, and that's that one. And this one is the common, not the common difference, difference of squares, okay? Expansion formula, then you get that. And x squared, they cancel, hence d squared has to be 0, hence d equals 0. What that means is there's no common difference. In other words, those three terms are exactly the same as you were asked to prove. Question 18, similar sort of thing, but a bit more algebra. You were told that these three terms form a GP. Okay, so same sort of deal going on. Square of the middle term, which is this, is equal to the product of the two end terms, which is that. Okay, now from this line on, this is all algebra. So again, binomial product formula. So that's a squared plus 2ab plus d squared equals, expand it out, you get that. And a squared here, a squared there cancels. So you've got 2ad plus d squared equals 4ad. And move that one over to the other side, you get negative 2ad. And take the d out as a common factor, so you get d equals 0 or 2a. So one case at a time. The first case is common difference is 0. What that means is going back to the original sequence, this is all A, and A, because these are all 0, okay? So we've got a constant sequence, okay? Just like in the previous case. But the second case, when the common difference is twice the first term, okay? So that means you can rewrite these in terms of A, that's going to be A, and D is 2A, so that's now 3A. Here, 4 times 2d, sorry, 4 times d, which is 8a, plus a, which is 9a. So these are the three terms in that sequence, which form odd positive integer, multiples of a, because a is a 1, and 3 is an odd power, and 3 is an odd integer, 9, so is 9. So it, meets the question, okay, the condition for the question to be proved. All right, so that was rather a long video because it's got a lot of questions in it, especially under the development section for this 1D. And I'm sure it helped you, this video will help you guide through your set of questions to be done, okay? So that about does it for this video, and I'll see you guys next time.